Okay, so last time we spent time going over perimeter and area. Yes, perimeter and area. That's what we did all of last time, right? Okay, so we are going to spend a little bit of time on transformations first today, and then we will finish up all the able stuff. Okay, so transformations is pretty quick and easy. So I want to go over that first. Okay, so transformations. What are transformations? Yes, picture and you do all the things with it. So we have three different types of transformations. The first type of transformation is a translation. And a translation is a slide, okay? It's literally just picking it up and moving it to the left, to the right, up, down. You don't turn it, you don't flip it, it's just sliding it around, okay? So we have one type of translation, oh, sorry, one type of transformation is called a slide. Sorry, it's called a translation, which is a slide. And the way most people try to remember this is there's an SL in both of them, translation and slide. Okay, so this could be just literally as easy as just moving it up, moving it down, moving it left, moving it right. You can make it a little more difficult and say it needs to be translated by this vector that is 2.5 units long, so it needs to move this direction 2.5 units, so on and so forth. But essentially, it's just moving it around. That's the easiest of all the transformations. The second transformation is a rotation. And what does rotation mean? Yeah, turn it. If those both have a T, rotation is turn. So you can turn it. Here you go, here's a picture. Little frog. You can rotate clockwise, you can rotate it counterclockwise. You can rotate it. So I think on your homework, it tells you to rotate it. Let me actually look before I sit here and tell you what it tells you to do. I'll find your homework first. Yes, a quarter turn, a half turn, so on and so forth. It tells you to take the shape and do a quarter turn clockwise, half turn counterclockwise, then a quarter turn. So this is a quarter turn. Like a half turn would be flipping it upside down. A full turn would be all the way back to where it was, right? You could also do this with degrees. This is a 90-degree turn. 180-degree turn would be all the way down. 360 degrees would be all the way back up. 270 degrees would be 3/4 of a turn. We're not going to do the degrees, but rotations can be done a few different ways. Okay, you can rotate things about a point. So you could say rotate it about this point in the middle. And so literally it would need to stay in the same spot and it just needs to be flipped upside down. Or you could rotate it about a point. So it's like it needs to move around that point over here. You could say it's like a point right over here. You could say it's a line. There's lots of ways to do rotations. Okay. And here we're just going to literally say like on your homework, it gives you this. And it says rotate it a quarter turn clockwise. So you would do a quarter turn clockwise. Some people really, really, really struggle with this. And let me give you a little hint if you really, really, really struggle with this. If you really, really struggle with this, the best way to do this problem is to take a piece of paper and cut it. Oh, give me some scissors. And you cut it out to that shape-ish. It doesn't have to be perfect, but the idea is cut it out to make it look like that shape. Something like this. So here's my initial shape. It's not the exact thing, but you get the idea, right? If I do a quarter turn clockwise, am I turning it to the left or to the right? To the right. And how many times am I turning it? Like one time. Okay. So if I do a quarter turn clockwise, it looks like that. Okay, then a half turn counterclockwise. So you would like pick this up and draw this right there. To do a half turn counterclockwise, am I turning it to the right or to the left? To the left, how many times? 2 times around. So it's going to turn this way is 1 turn. This way is 2 turns. So you draw that there. And then a quarter turn clockwise. So here, a quarter turn clockwise is 1 turn to the right. So you're back there. Does that make sense? So if you struggle with this, literally cutting out a sheet of paper, it doesn't have to be an exact thing, you know, like just essentially is the idea. Cut it out and literally move it around how you need to. Okay. So that's rotations. We're going to do some in just a minute altogether. The last one is reflections, and this is the most fun one, I think, personally. Reflection is a flip. You can reflect things horizontally. It's like a mirror image. So notice it's not just moved over, it's literally flipped over. You can reflect it vertically. You can reflect it across a diagonal line. Like there's a line of reflection though that you're doing it. Okay. So we actually have for reflections, this is a flip also, sorry. And a way you can remember that is the FL reflection is a flip. And we actually have a tool that we can use for reflections. Let me think where they're at. Right here. Called Mira's, M-I-R-A. All right, wait a second. But that's not what I got. Okay, so these are called Mira's, M-I-R-A. They look like this. I'm recording is why I'm doing everything on the document camera. And there's a top and a bottom. If you look real closely, there's like a really flat edge and then an edge that kind of has a diagonal on it. You can kind of see the line up here on the camera. See the side with the diagonal? The side with the diagonal is the part that goes down on your paper. Okay. So what this does is it creates a reflection for you to like trace essentially. So for example, let's draw a random triangle on page. Any triangle, doesn't matter what it looks like. And then I want you to draw a random diagonal line on your page somewhere. Doesn't matter. What we're going to do is we're going to reflect this triangle across the line. To make it perfect, if you wanted to really make this perfect, you'd have to get like a ruler out and measure how far is this vertex right here from here. And then you'd have to have like go past it over here and then the same thing over here, the same thing over here. Would you agree that would be kind of a pain in the butt? That's what this mirror is for. So what you do is the side with the little line on it that's not flat, you put that down on your diagonal line. And then you look through the side with the triangle. And if you look through the side of the triangle, you can kind of see it. It reflects the picture. You can kind of see it up on the projection. You see how it reflects the picture a little bit right there? And so you can look at that and you can see where your hand is behind it in red and then draw it. Does that make sense? I can show you how to do it if you're having trouble. Look through. So that's your line right there. Look through this side. You see how you can triangle, and then you can draw on that side and make it match.
Oh.
So again, you're looking through the side with the triangle on it. So you're looking through this side of the mirror, and you do your best to draw it as perfectly as possible. And when you do, it should kind of match up. Like if we folded it up on the line, if you folded it perfectly on the line, your triangle should match up. You can kind of see through. Mine kind of match up. Okay, so again, if you're watching this, you can kind of see, like, right. I gotta redo it. If I was reflecting it over this way, you can kind of see how, like, right over here, that's a reflection, because that's not actually drawn there. So it's the reflection, and you use your pen to draw over it. Okay, hope you can see that on the video. Okay, so there are all kinds of really fun activities you can use with that. You can print off, I did not, because we're not gonna spend our time in class today doing it, but you can print off all these fun little pictures where it has half of it, and you put your mirror right there, and then you can draw the other half. That's actually a really good picture on the video. You can kind of see the other half. I mean, there's all kinds of fun things you could do there to, there you go. That's a better reflection right there. To draw the other side. So there's a lot of really fun things to do with reflections. Unfortunately, we don't have just a ton of time to spend on it today, but I do want to give you a practice paper to work through. We're gonna work through it together. It doesn't have translations on it because I have a full confidence that you can just move something around. Okay. On your homework is a dot on a coordinate plane. It tells you to move it up 3, left 4. I got full confidence that you know how to do that. We're just gonna practice the other two, the translations and the reflections. So let's start off with translations. Nope, the rotations. I'm sorry. The rotations and reflections are the one we're doing. Translations, I have full confidence you can do. So this arrow, I want to turn this a quarter of a turn clockwise. So clockwise means you're going to the right, and a quarter turn is 90 degrees. So again, if you needed a piece of paper, you could use a piece of paper. Sometimes in previous semesters, I've said, like, take your phone if you really struggle with this. Like, some people really have a hard time with it. If you do, take your phone, take a picture of it. If you take a picture of it, now that you have this picture, now turn it that way. Like, do a quarter turn and there it is. Okay, and then turn it that way or whatever you need to. So feel free to do that. I'm not gonna let you use your phone on the test, but I'll let you use a Post-it note, and you can cut out the shape with Post-it note on the test if you want to. Okay. So if I'm gonna do a quarter of a turn clockwise, this arrow turns sideways to the right, and it's gonna look like
When is the test, by the way?
the week. Oh, that's terrible. The week after Thanksgiving. We come back from Thanksgiving.
Do we have class on Tuesday?
No, let's go ahead and talk about that real fast. As you finish that one. So on Tuesday, remember, we're squeezing in all the information, so we have no class on Tuesday, but your geometry projects still do. Okay, so you have some options. So the geometry project is still due on the 23rd, which is Tuesday. Is that the correct date? Okay, so if you are turning in a digital copy, you can just turn it on D2L, not a problem. If you want to, if you have like actually a book to turn in, you can turn it in. I'll be on campus this whole time. So I'll be on campus tomorrow. I'll be on campus on Monday. I'll be on campus on Tuesday. So you can find me, you can put it under my office door, you can stick it in the thing outside my office door. There's like a little basket. So if you want to turn in a hard copy, you still need to turn it in by Tuesday. Okay, whenever you want to, there's a basket outside my door. If I'm not in my office, you can put it there. Or you can turn it in on D2L digitally if you want to do a PowerPoint or a whatever.
Can we scan it if we do like a booklet, or you still would want like?
It's gonna be so many pictures and so
Yeah.
much, like, because it's like a 20-page book. So I think it's gonna be a whole bunch more work than it is to either choose. If you haven't done it yet and you don't want to come up here, I'd do a digital copy. So like, however you want to do it. Okay. Questions about that? When we come back, that would be the 30th. So son's birthday. I thought something was due on the 30th. Something due on the 30th.
Probably just.
How old's it gonna be?
3.
Jesus.
No,
No, it wasn't.
something was due that day.
Sorry.
So that day is we're reviewing for exam number 2, and then the 12-2 is exam number, I say 2, number 3, exam number 3. And I will post the review for D2 for exam number 3. I'm gonna post it on D2L like this week, so you'll have it over Thanksgiving break if you want to work through it. I intended to have it copied and handed out today, but that didn't happen. So I'll post it on D2L if you want to have it, and I'll pass out a hard copy on Tuesday, and then your exams on Thursday. Good with that?
Can you say all of that again?
You'll pass out.
Review, this review is gonna go on D2L today or tomorrow. If you want it to work on it over Thanksgiving break, but I'll give it to you on the 30th if you need a hard copy. After that is final exam review and final exam in here. So after that's final exam review and final exam.
Yeah.
It's on Tuesday. Final exam is on Tuesday, the 14th at 10:30. 10:30 to 12:30. Okay, so like we're almost done. Last lesson, basically. It's a reflection and rotations. Just something like that.
No.
Okay, so this one, this piece, we're gonna take this and turn it a half turn counterclockwise. So is that turning to the left or to the right? To the left, so I'm gonna pick this up and turn it left 90 degrees one turn. So it's like I'm turning my paper like this. I need to draw that in that
I
box.
don't know how to draw it.
I mean, it doesn't be perfect. Okay. It's like the idea is if I'm looking at this now, I need to draw a flat side on top and the thing sticking out on bottom, right? If you draw something flat on top and something sticking out on bottom, good enough, right?
Do you want us to move on to the back?
Sure, you can.
Or-
So it doesn't have to be perfect.
Is that not a?
You're right. I did it wrong. So I did a quarter turn. What's a half turn? One more. So a quarter turn counterclockwise is that. A half turn counterclockwise would look like this. So I need to draw my flat side on the left. It's sticking out on the bottom on the right. Flat side on the left. Sticking out on the bottom on the right. Something like that. For the next one, kind of like a backward Z looking thing. Turn the shape a quarter turn, so one time counterclockwise. So I want to turn my paper one time that way. And when I do that, the bigger piece is on the left sticking up, the smaller piece is on the right going down. That's what I want to draw. Right?
We just need to get the basic idea, like you're not gonna penalize this if it looks like crap, right?
No, but I need you to do enough. I need you to make this side look bigger than that side. Does that make sense?
Yeah. Okay.
Okay, so again, quarter turn is turn your paper one time to the left. So when you're drawing this, you need to draw, I'm drawing the board so I can match it up first. Just make sure that one was bigger than that one. Or even if you wanted to, another option, another thing that might be helpful. And I'm happy to let you use this on your chest if you wanted to. You can use patty paper. Patty paper, I think I showed you this the other day, is like wax paper. But you could start off by tracing your initial one. Let me get a marker that works on this. Come on. Here it is. Okay, and if I take that and turn it a quarter turn counterclockwise, it needs to look like that. And so then you could draw that on your paper.
So we can do that on the test, right?
Yeah, if you want to use this on your test, you can. Okay, this half circle, if I want to turn that semicircle. If I want to turn that a half turn clockwise, that's a quarter of a turn. That's a half turn. So it needs to look like that. And then the last one, take a second to do that, a quarter turn counterclockwise. Quarter turn counterclockwise, maybe that. Something like that. Questions about that? Good with that? Okay, if you look at the other side, this is the fun one that you get to use the mirrors on. So draw the other half. You could literally do this without it if you wanted to, but it's a little bit more fun if you do it with it. Hey, the little chippy, the part that's like come out, make that face away from you. It's like that has to face down, but also needs to face away. So you know this little part that has a chunk cut out?
Yeah.
Make the smooth side face your image. Make the chunk be on the other side.
Okay. I wonder all mine.
Well, this will fix it for you.
Thank you.
It's still kind of hard. Oh. Is it the other way? Did I do it wrong? No, because that didn't really match. No,
Turn these in.
nah. This is just practicing class. There's all kinds of stuff to do. Okay, so when you there's some that are easier just to do, I feel like by hand, and some that are easier to do with the Mira. That one was not easy, but this one's not bad. Something like that. Okay, so on your homework, I gave you problems for the reflection where it gives it on a coordinate plane. So it's a little bit easier to do. You don't have to, you can still use these if you want to, but it's a little bit easier. So the idea is to reflect this across the line, this triangle across that vertical line. It is currently 1, 2 boxes away diagonally from the line there. So you need to do 2 more boxes on the same diagonal to be on the other side. Same thing here for this end. It is 1, 2, 3, 4 diagonal boxes away. So it needs to be 1, 2, 3, 4 on this side. And then for the L, it's 1, 2 diagonal boxes away. So 1, 2 would be right here. And this is your new triangle. You don't have to draw the diagonal lines if you can just handle jumping or whatever. But the idea is you can't just like draw it 2 away over here. You have to make it on the same diagonal line. Okay, same thing with this one and with that one. So you should be good with that. And the translation ones is this dot, move it 4 up, 2 left. Full confidence, you can put your dot on the paper. Okay, so that's kind of what the level of transformations we're doing here. If we had more time, there's a lot of really, really fun stuff you can do transformations. One of thing that I do want to talk about just for a second, I'm not going to spend too much time talking about it, but it's called a tessellation. You may know what a tessellation is. Sounds like something in Alan's face. Say something. Okay, a tessellation is basically something, it's a shape that like tiles the page is the idea. So like it's a shape that's moved. It could be just translated. It could be rotated. It could be reflected. You can do lots of different things with it, but it basically just tiles the page. So the idea is we see this all the time with rectangles, right? You can do your, pretend like it was the same size. Can't I cover this entire page with rectangles like that? Could I also make it look like bricks and offset them? And use the same? Couldn't I cover the whole entire page like that? Okay, so we can do it with squares and rectangles. You can also do it with other shapes. In geometry, you'll spend some time figuring out exactly what shapes, if you take geometry after this, exactly what shapes can tessellate, which ones cannot. So a hexagon is a great example of a shape that tessellates because there's something that you know that is hexagons tessellating. A beehive, right? All day. We could do this all day, right? And they match up perfectly. And it could fill the whole page, right? So hexagons tessellate, triangles tessellate. We also have tessellations that are a combination of like a pentagon and triangles or whatever. So there's different types. Monohedral tessellations are the same shape over and over. And then you have things, you don't need to know all this. I'm just giving you some stuff. We also have, let me look it up. I didn't bring it with me because I wasn't actually planning on talking about this, but there is an artist. His name is, his last name is Escher, E-S-C-H-E-R. Tessellations. So these are called Escher tessellations, and they are art, literally beautiful. Okay, so here's an example. Oh, let's make that bigger. How can I make that bigger? So this is a tessellation. Oh, don't go into all that. So here's some examples, like this one right here. Let me move that down. So you can't see it very well, but this is, it's like a lizard. So like this lizard, it's turned so that like the head right here is now the head on this green lizard, and it's the head on this yellow one. So it's like, that's like a weird shape that he did all different stuff with. He has like a ton of really famous artwork. This is a really famous one. So this isn't like a perfect tessellation, but it's like an artwork idea of it. But it starts off with birds, and then they slowly get closer together, and then the outline turns into fish. So like you can see the birds here still, the fish there. Okay. Another one that's really popular is called it's called Heaven and Hell, I believe. Oh, this artwork's in our department's head office, and I could like look at this all day. This is beautiful. But they like these birds, and they have the outline of the birds, and it's like night and day. It's just, you could spend a lot of time looking at them. There's another one called Heaven and Hell. Let me look that up. There you go. So it's a circle, and if you'll look at the dark image, it's like supposed to be like a demon, but then the white image is supposed to be like an angel. It's just really cool. So if you're spending time in geometry and you're spending time on translations and rotations, a tessellation is a really fun activity that you can do with the kids, that the kids that don't love math but really love art could really enjoy. And you can do it really, really easy because you could do just these boring shapes like that, or you could take something like,
We did that in middle school.
you did in middle school? Was it fun?
She gave us like the index card.
That's what I was about to do. I was looking for an index card. You could do an index card. I'm gonna do this Post-it note. But you could take this Post-it note and use your scissors and cut out some weird shape. If I had index card, whatever shape you wanted to, and put it on the other side. So like, oh, you can't see that. That would tessellate now, right? Doesn't this part match that part? Yeah, because I cut it off. You could do it on the top and on the side and have this shape and then like trace this and pick it up and move it and trace it. And index card would be better because it's like harder to work with and you tape it together or whatever. And so you can like make tessellations that way and color them different and all sorts of things. So that's a application of transformations. Okay, so those are tessellations. It's a really, really fun application of transformations if you have time for it. Okay, so I'm gonna spend the rest of the class on angles because we need to spend the rest of the time on angles. But this was also a really fun little activity. And so I'm gonna let you do this as bonus if you want to. Have I given y'all bonus in here yet? Bonus assignment? No, I'll give you 15 bonus points on homework assignment if you turn this in. I did it literally while I was waiting on my copies to be made, so.
You want this today or?
Oh, no, turn it in after Thanksgiving.
Cool. Got it.
Then you can actually turn in a hard copy.
No,
So this was just a fun little activity of taking this rectangle and doing all this stuff with it. And it makes a picture. You'll see what it is when you're done. If you do not recognize what it is, you're wrong. It's a word it makes. I did it with highlighters, but you can do it with whatever.
But when it says reflecting down,
So this right here, the idea is, here, I'm gonna use my little Post-it note. This is a 3x3, right? So when it says to take this and reflect it down, you're literally flipping it down. So it's gonna be the three things below it. And it's, so the first thing you do is reflect it down. So then you color that in. Then it says reflect it to the right. So then I flip it like that, and I'm coloring those three right there. Okay, and then it'll tell you to move to a different place and then turn it 90 degrees, reflect it right. Oh, that's where I messed up. I messed up at the at the end. I had one part that wasn't right. When it says move it over here, I'm gonna say it said move it right here. Let's pretend like it's right there. And it says turn it 90 degrees around the middle square. That turns it like that. Do you agree? Around the middle square, it says keep the middle square, just turn it right. When it says reflect it right, which way are you reflecting it? For whatever reason, I had turned my paper to shade it this way, and then I tried to reflect it up that way, and I messed up. Reflect it right means flip it over right. So if you turn your paper to shade it, turn it back normal before you start flipping it again, because right means this way, okay? So at the end, it'll make this word, okay? So that's due after Thanksgiving. For bonus points, if you want to do it, I said 15 bonus points on a homework assignment. Some of you need it, some of you don't. If you don't need it, don't do it. It's up to you. But some of you might need a little extra help. Okay, so let's talk about the angles. I also have one other thing I want to show you. Yeah.
Sorry, over the bonus homework, so when it moves to the next one, is it like the original image, or is it the one that we just worked on and then it continues?
I wonder that too, but it gives you the specific coordinates that it has to fit into.
Okay.
So you'll see which way it goes. If it goes this way or up this way.
So like when it says reflect it down, then reflect it right, is it that original one that it gave us, or the one that we just like?
Well, if you'll look, you're moving it to 10-4. So 10-4 is this dot, 10-7 is this dot, 11-4 is this dot, 11-7. You only got one option there.
Right, but sorry, I don't know if I'm making any sense. Like for number one, it says reflect it down.
Mhm.
Number two says reflect it right. Which one are we reflecting right? The one that we just drew?
The one you just drew.
Okay.
Yes, it builds off the one before it. So that I understand what you're saying now. She said that the first number two says reflect it, or sorry, number one says reflect it down. You get that. For number 2, it says reflect it right. What are you reflecting right? The thing you just
So it's
reflected
just like
down.
you're continuing.
Yes, continuing until it tells you to move. Once it tells you to move, it'll make it go sideways or up and down, and then you go from there. Okay. It really is pretty, like, don't overthink it. It's really straightforward. This is like a 3rd grade activity, so it's really straightforward. Okay, so let's keep on going with the angles, because we did some stuff with the angles before. And at the end of this, I really hope we have time, because I printed off the math part of your, technically you've taken all your math classes if you are a EC through 6. Okay, if you're a middle school major or a high school major, you still have more math classes to take. If you're not, you're done. This is all the math classes you're taking, so you should be prepared to take the math part of your test. So I printed off sample questions for us to kind of look at, okay? Let's go through angles real fast. I'm just going to spend time talking about the major, like I'm not going to go back over the definitions and stuff. Let's review the major things, the exterior angle of triangles.
You said the math part of our test, like for teaching,
Yes.
and we have to take that even if we're not planning on teaching math.
If you are a ECE or EC through 6, is it generalist? Is that what it's called? There is a test that you have to take that has a math part, a reading part, a blah, 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 all that
It's
kind of
4th
stuff.
through 8th.
4 through 8 is a specific general, like as a math. Yeah, you have to take a math content test. Are you 4 through 8 what? General?
4th through 8 English.
English?
Yeah, I don't know. They told me I had to take it. I was confused too.
You take class before this?
Yeah,
Yeah, what do you
yeah, I
mean?
took
What
it this
summer?
summer, yeah.
Well, I don't think you need this class, but ignore this next part. I pay attention to the angles, but then ignore when we go to the test part.
So I'm not gonna have to be tested on over this if I'm 4th
If
through
you're
8
a 4
English.
through 8 English, I mean, don't quote me on that, but
No, I believe I'm studying right now for my test, and I think he's just gonna have to take.
a 4 through 8 English test, because I'm teaching a class that you take a 4 through 8 math test, and they're not in English. I mean, everybody has to take reading, right? Even if you're a high school person, you take the reading, but you shouldn't have to take
This
math.
is some bullshit, man.
Maybe it's like an elective for you, and you won so much, haven't you?
I have.
You loved it. Okay, so exterior angle triangles, that says if you have a triangle,
Lucky your
You
class is actually.
can extend it, right? You can extend it over here. And if I wanted to find this angle right here, and I'll say this is, we're gonna call this angle A, angle B, angle C.
Well, I'm sorry, did we ever actually write down the definition of tessellation
No,
or?
it's
No?
just extra information. It was just fun. I didn't want to skip over it because it was fun to go.
All
over.
right.
It's tiling a plane with a shape,
All right, I'm sorry.
with a shape or a set of shapes or whatever. But it's tiling. You have to cover all the area. You can't have any gaps in it. That's what makes it tessellation. Okay, so an exterior angle of a triangle is the sum of the 2 non-adjacent interior angles. We went over this before. So in this case, this picture, what's the measure of this angle right here? A plus B, right? It's the sum of the 2 non-adjacent interior angles. Agreed? Or you could also do 180 minus C. What are those called? A linear pair, because they're on a line. Okay, so if I gave you a problem, let's make up a problem. And I said this angle is 73 degrees and this angle is 49 degrees. And I wanted you to find, this is not drawn to scale because I just made this problem up. And I want you to find this angle right here.
Do we subtract those?
So this angle is the sum of the 2 non-adjacent interior.
Oh.
So 73 plus 49 gives you that outside angle. Mhm. Yeah, so 73 plus 49 is 122. And that's what this angle would be, 122 degrees. Is there a longer way to do that?
Is that like what happens each time? Every time? Okay.
If it's an exterior angle, it's the sum of the 2 angles that are not connected to it.
So every time it looks like that.
I mean, sure, make the triangle look like. It's that one, which 2 angles would be?
Yeah.
That one, that one.
Mhm.
It's the 2 that are not touching that angle.
Right.
Okay. Again, is there a little bit of a slower process to get this? Is there another way to do it?
Would you add 73 plus 49 minus that from 1A.
Why'd you subtract from 1E?
Because all interior angles add up to be 180.
Yeah, the interior angles of a triangle, inside a triangle adds to be 180. This becomes 58 degrees. Now can I figure out that other one? Yeah, they're a linear pair, so 180 minus 58 gives you 122. It's just like you did a lot of extra work to get there. Can you still get it that way? Yes. Okay. So that was one thing we went over. The other thing we went over was vertical angles. What are vertical angles?
Intersecting line.
Intersecting lines create vertical angles. So if I had a 1, 2, 3, 4. Give me a set of vertical angles. 1 and 3, because they're angles across from each other. It's very obvious that they're congruent, right? They may have the same measure. What's the other set of vertical angles? 2 and 4. Okay, so angles across each other on intersecting lines are congruent, are the same measure. Cool. Okay, we're about to get into parallel lines and all the things that go with parallel lines. Before I do that, there are 4 sets of angles on parallel lines that we deal with and are very important. Before I do that though, let me let's define some words because it's going to make you it's going to help you remember things better. Okay, what does alternate mean? Or alternate? Opposite, right? So it's like I'm alternating across a line. I'm flipping back and forth across the line. Okay, so if this is my line and I want to alternate, I would be here and then I jump over to here and then I jump over to here and then I jump over to here, right? I'm alternating across that line. Everybody agree? I'm going to give you alternate exterior angles and you need to know what those are. And I'm trying to like define different words so that it helps you. So alternating is like these two are alternating because they're alternating across the line. Now these two are alternating and these two are alternating. Agreed? What about exterior? What does exterior mean? Outside. What does interior mean? On the inside. Corresponding or corresponds. What does correspond mean? There's a couple different definitions of it.
Like they're next to each other or together?
They're the same. It means same. Okay, so let's say same position. They got stuff that go together with them, but they're the same position is the idea. What's the other one called? I gotta remember. Oh, and the last one is consecutive. What does consecutive mean? The one right after. Consecutive numbers would be 2, 3, 4, 5. So right next to each other. Okay, so if you could understand these words, then when I ask you which one's an alternate interior angle or consecutive angles or blah, 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 it's not quite so bad. Okay, the words really do help. So the idea for all of these sets of angles is we have a set of parallel lines. What are parallel lines? Lines that never intersect. They have the same slope from college algebra. So lines that never intersect. So for example, if I have line L and line M is parallel to it, let's call this line L, I call this line M. Those don't look very parallel. What's the little sign that shows that they're parallel? You can put little dashes. Lots of times you'll see an arrow. That's how I'll do it, because that's how we do it in geometry. And the geometry textbook does it that way. So one set of arrows, if you have two sets of parallel lines, you would say like I'm not gonna draw a picture right now, but pretend like I had two sets of parallel lines here. Here was my other set of parallel lines. I wouldn't use one arrow for these because then that would say they're parallel to these. So I'd use two arrows to show that these two are parallel to each other. Does that make sense? Okay. So we got parallel lines, and then you have a line that cuts them some way, shape, or form. It could go this way, it could go the other way, it could go straight up and down. Like, it doesn't matter anything about that line. Do you know what that line's called? They could be perpendicular. How could it be perpendicular? If it created a 90-degree angle. Okay, so perpendicular lines create, or lines that intersect that create a 90-degree angle. If it just creates any angle, does anyone know what that's called? It's called transversal. Okay, and the reason why that matters is because in the definition of all these angles that we're about to write, they say, given a set of parallel lines cut by a transversal, the blah, 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 blah. Okay, so all of these come from this picture right here. This picture could have this transversal going the opposite direction. It could go like this. It could be like straight up and down. Like, it doesn't matter what that transversal looks like. It just literally crosses both of those lines. Okay. So we have some different, let's put our words with this picture. I'm alternating across the transversal. Let's number our angles real fast so that we can talk about them. We call it 1, 2, 3, 4, 5, 6, 7, 8. Your test, this is what your picture is going to look like. I may make the line go the other way, but it's just going to be in numbers. I want you to, instead of like saying angle A, B, C, angle C, D, E, this is easier to talk about them with numbers. Okay, so tell me two angles that are on opposite sides of transversal. They're alternate angles. 1 and 2, 1 and 4, 1 and 6, 1 and 8. Those are all alternate angles because one is on the opposite side of the transversal than the other ones. Agreed? What about 3? Give me 4 angles that are alternate of 3. 2, 4, 6, 8. Agreed that all those are on the other side of the transversal than 3. What about for 6? Give me 4 angles on an alternate side.
1, 3, 5, 7.
1, 3, 5, 7. Okay, does that make sense what alternate means? It means on opposite sides. Okay, so now interior and exterior, we're talking about the parallel lines now. So parallel lines, interior is inside the parallel lines, exterior is outside the parallel lines.
Okay, so 3, 5.
So tell me 2 interior angles.
3 and 4.
3 and 4, 3 and 5, 3 and 6. Those are all your options. Tell me 2 exterior angles.
1 and 2.
1 and 2, 7 and 8, 1 and 7, 2 and 8. Any combination is fine. Okay. Tell me some vertical angles here. Vertical is 2 lines that cross that make an X. 2 and 3, 1 and 4, 6 and 7, 5 and an 8, 5 and 8, 5 and 8. Okay. The other thing was corresponding. So angles corresponding, we said same position. So same position, angles that are in the same position would be like 1 and 5 because they're on top of the parallel on this side of the transversal. Everybody see that? 3 and 7 are corresponding angles because they're on bottom of the parallel line on this side of the transversal. Okay, 8 and 4, bottom of the parallel on this side of the transversal. 2 and 6, this side of the transversal, top of the parallel. Did you see how those are corresponding?
Okay.
Consecutive is ones that are right next to each other, but not a linear pair. Let's talk about linear pair first. Which ones are linear pairs? We've got lots of them. 1 and 2, 1 and 3, 3 and 4, 4 and 2, 5 and 6, 5 and 7, 6 and 8, 8 and 7. Those are all linear pairs. So consecutive are ones that aren't linear pairs, but next to each other. So 3 is not consecutive 1 because they're a linear pair. 3 is consecutive with 5. They're not a linear. Oh, what's a linear pair? Is that what you said? They're on a line, straight line, a line in between them. Okay, so 3 and 5 are consecutive. I have one more set of consecutive angles on this.
4 and 6.
4 and 6. Those are the only set of consecutive angles. I should do it like that. These are a set of consecutive. These are a set of consecutive because everything else would be a linear pair. Does that make sense?
Mhm.
Okay, so I got 4 different situations here. that make either congruent angles or supplementary angles. What does supplementary mean? There you go, add to be 180. Almost all of them are congruent though. Let's first talk about the alternate interior angles. Alternate interior angles. So that's two different words. They're alternating, so they're on opposite sides of the transversal. They're also interior, so they're inside your parallel lines. So which angles switch back and forth from the transversal but are inside the parallel lines? 3 and 6, because they're on opposite sides and they're inside the parallel lines. What's the other set? 4 and 5. If you need a little bit of help of seeing this, these are like the inside of a Z. If you look at your Z here, that side and that side, you see the Z? When I was in geometry in high school, we called this the Z property. Okay, the only problem with this is it also works the other way. It's like a backwards Z. It's not very easy to see. The 3 and 6 are also alternate interior angles. Okay, so the theorem says that if you have two parallel lines cut by a transversal, alternate interior angles are congruent. Okay, and this is the angle pair that is on opposite sides of the transversal, but inside the parallel lines. So opposite sides of transversal, inside parallel lines. And they are congruent. They equal the same measure. And this is really, really great to know, because if I tell you one of them, you can basically figure all the rest of them out. Let's say I told you this one was 75 degrees. Angle 4 is 75 degrees. Which one is congruent to angle 4? Angle 5 is also congruent. They're alternate interior angles, so this is 75 degrees. Agreed? Okay, I can also figure out 3 and 6 from this. How can I figure out 3 and 6 from this? Aren't these a linear pair? So I can do 180 minus 75 gives me 105. So that makes this one 105 degrees. What's that one gonna be? How do you know it's 105? Okay, these two are alternate interior angles, so this one is congruent to this one. Makes it 105, or you could also do the linear pair again. Okay, does that make sense? Alternate interior. Okay, let's go to the one that's closest to that, alternate exterior angles. I lost my black pen somewhere, so I've switched over to a red pen. Alternate exterior angles.
Is that your black pen right there?
Probably. I'll come get it in a second. Okay, so they're still alternating across the transversal. So they're still on opposite sides of the transversal. What does exterior mean?
Yeah, so
Outside of the parallel lines. So they have to be on opposite sides of the transversal and outside your parallel lines.
would that be 1 and 8 and 2 and 7 on this?
Great job. So finish writing the definition. These are also congruent. So I'm gonna show you. Go back up to your picture. So outside of the parallel lines would be like angle number 1. What's the angle on the other side outside the parallel lines on the opposite side of the transversal? 8. So 1 and 8 are congruent. There's one other set of alternate exterior angles. 2 and 7. And I tried to draw my slanted enough that you can kind of see like this is an acute angle and that's an obtuse angle. Like 1 and 7 are not congruent. Depending on how you draw your line, you can't see it very well, but I tried to draw it where you can see it really well here. But 2 and 7, 1 and 8. Everybody understand why they're alternate exterior? Okay. So like on your test, I'm gonna give you 2 types of problems. One type of problems, I'm gonna give you this and say, give me 2 alternate, give me a pair of alternate exterior angles. Okay, so if you can remember, alternate means opposite side, exterior means on the outside, you should be able to get 2 angles, right? Okay, let me go ahead. I did not write this down a second ago, but on my paper, but let's go ahead and list the pairs of alternate interior. We said it was angle 3 and angle 6. Also angle 4 and angle 5. And then your exterior pairs would be 1 and 8, 2 and 7. Everybody good with that? Okay, there's 2 other ones. These both start with the letter C. They're called corresponding angles is the first one. You're going to geometry. This one's super important. It's how you prove all the rest of them is with corresponding angles. What does corresponding mean? Same position. So these are angles that are in the same position. Corresponding angles are congruent. Okay, and that should kind of make sense. If they're in the same position, then they should have the same measure. Okay, so going back up to our picture, we have lots of corresponding angles. Look at angle 1. What angle is in the same position as angle 1? 1 and 5 are in the same position. So they are congruent. What angle is in the same position as 3? 7. What angle is in the same position as 2?
6.
Would be 6. And the angle in the same position as 4 would be 8. Does that make sense? I'll write those down in just a minute down by corresponding angles. But they're in the same position, so it should make sense. 1 looks just like 5. 3 looks just like 7. Okay. Okay, so that's the reason why I'm not putting it all in this picture. Like it's way too much if you put it on one picture. Okay, so 1 and 5 is a corresponding angle. We said 3 and 7. We said 2 and 6 and 4 and 8. Questions about that? If you like the whole idea of like the Z, if you liked that picture, in high school, we called this the F property. And the reason why I called it the F property is because these lines kind of make an F and they're on the insides of your F. Okay. The last one, alternate exterior angles, didn't have one, or I don't remember if it had one. It didn't stick very well. The last one are consecutive angles. So consecutive angles are angles that are right next to each other that aren't a linear pair. Let me see if I have an actual definition of that. Consecutive angle pair in the interior on the same side of transversal. That's a lot to remember. So let's say next to each other. If you can just remember next to each other, not a linear pair, that should be sufficient. Because there's literally no other options there. But that's not the actual like geometry definition, FYI. Again, let's go back to our picture. Which angles are next to each other but are not a linear pair? The only option we have are 3 and 5 and 4 and 6. And We called this the C property because it kind of made a C. And those were the sides. Okay, so 3 and 5 and 4 and 6 are the only consecutive angles. F is the corresponding angles. Okay, and let's kind of look at this. Look at 3. 3 is an obtuse angle and 5 is an acute angle. Are consecutive angles congruent?
No,
Are they the same measure?
no,
No, but don't they look like they add to be 180 degrees?
yeah,
And the reason why, the proof is, if these are the same measure and these are a linear pair, shouldn't these also have to add to be 180? Yeah, so consecutive angles are the only ones that aren't congruent, those are supplementary. Okay, so the ones, this was 3 and 5 and 4 and 6. These are supplementary is the word, and that means add to 180 degrees. So it's like it's the only ones that aren't a linear pair, but they still kind of follow the same rules as a linear pair because they add to be 180. Okay, so the things I need you to have from these, if I give you this thing and I make you list me out an alternate interior angle, an alternate exterior angle, consecutive angles, and corresponding angles, that's one thing. The other thing is if I give you a somewhat simple problem, not super difficult. Okay, so let's do one of those. So you got 2 parallel lines. These are the parallel ones. And then you have 2 transversals and they make an X. So they look like that. You got a whole bunch of angles here, right? Let's number them so that we can all kind of have the same picture. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 different angles here. Here's the crazy part about this whole parallel lines to transversal. To get every single one of those answers, I only really need to give you 2 angles. Let me see if I can just give you 1. That would be crazy. No, I have to give you 2. I have to give you 2. Okay, so the 2 angles I'm going to give you are, let me verify. I'm going to give you angle 1 out here is 40 degrees. And angle 6 is 50 degrees. And you can get the rest from vertical angles, linear pairs, alternate interior, alternate exterior, corresponding, consecutive, blah, blah, blah. Do you want to take a second and spend a little time on your own? Okay, I'm going to pass out that paper of the sample questions while you do that. You know what? I'm recording this and I'm writing all over the board, and that is not going to be recorded. That's awesome. I didn't even know that. I'm gonna give you 1 more minute and I'm gonna go through it. Sorry, I know it's not very much time, but I'm gonna move on.
not drawn to scale, right?
No, not at all drawn to scale. Never. Damn it. Yeah, I'm gonna go ahead and get started. We should be kind of close. If we do some vertical angles, angle 1 and angle 4 vertical angles, right? So this is 40 degrees. This is 50 degrees. What else can we do from here?
180 minus 40.
Yeah, 1 and 2 are a linear pair. So can't I do 180 minus 40 to get 140?
Mhm.
So this would be 140. So what else do I know?
30 is
3 is 140. Okay, can't I get 5 and 8 the same way? 180 minus 50 is 130. They're vertical angles, so boom. Okay, so as of now, you're stuck if you just try to do vertical angles. You got to bounce around to the other side. So remember, these are parallel lines. So technically, right here, look at number 4. I can do an alternate interior angle on the opposite of the transversal, would be 17. Do you see how that's an alternate interior angle? And then you can get that whole set of 4, right? Okay, so that tells me this one's 40 also. This one has to be 140, 140. Okay, so I got that whole set of 4. How can I get this whole set of 4 over here? Do the alternate interior angle the opposite way. You can also do exterior if you wanted to. If you did alternate interior the opposite way, that one's alternate interior with 14. If you wanted to do alternate, I always do interior, I don't know why, but if you want to do exterior, 6 and 15 are exterior, get you the same answer. You can then do a linear pair, subtract, you get 130, 130. How can you find angle 9? I don't have any type of parallel properties for that.
Triangle.
Oh, isn't that a triangle?
Yeah.
In this 90 degrees, when you add them up, is subtract 180, you get 90.
That's why I asked not drawn to scale. because that's
Never drawn
not-
to scale, never. Okay, so 90 and 90, and then I can subtract from 180, and this would also be 90, and this would also be 90. That's all of them. Was it that bad?
Not at all.
Yes, she said terrible. Okay, so we'll try to practice this more, but the idea is, did you have to do alternate interior? No, you could have done alternate exterior. You could have done corresponding. You could have done consecutive, like there's all kinds of stuff you can do with this, okay? It just kind of depends on what you see. Okay, so I want to take a second and talk about that paper. I don't have time to go, like I literally have like 2 minutes, but I want to take a second and show you some stuff that are literally problems we did in here. So it's broken down into all the competencies. This class does not cover all the competencies. One thing it did cover is, if you look at number, where is it at? Crap. Number 12 is obviously one. 12 is probability and statistics. We literally just went over that. Theoretical probability. They worked in groups to flip a coin. They got 9 heads, 6 tails. Which of the following observations made by students is about probability is accurate? Theoretical probability is 0.5, and it's equal to the experimental probability. Did they have, like their experimental is what they got? 9 heads, 6 tails. Is that half and half? No, so it's not A. Theoretical probability of landing on heads is less than the experimental probability. What is their experimental probability of landing on heads? 9 heads out of, so 9 out of 6? 9 out of 15 total tosses. Okay, whatever that is, it's bigger than 50%. Okay, whatever that percentage is. Okay, so is the theoretical less than the experimental? this is experimental. What is that number? What's 9 divided 15? 3/5, that'd be 60%. Okay, so that's experimental. What did we say the theoretical is? 50%. So is theoretical less than the experimental?
Yes.
Yeah. What about the next one? Experimental is lower than expected. Is 60% lower than what we expect to get? No, it's higher. We wanted to get 50%. And it would have been more accurate if they had decreased the number of trials. No, it'd be more accurate if they increased in the law of large numbers. Okay, that is literally a problem that we've gone over in here in a different form. Okay, another one that was a problem that we've gone over here in a different form is, I'm trying to find it. Oh, number 4. Which of the following activities is most effective in helping kindergarten students understand measurement of lengths of small objects such as pencils or cups? Would it be getting out a ruler and measuring with a ruler for kindergartners? No. Placing interlocking cubes next to the objects and counting the cubes? Yeah, probably. Cutting sheets of construction paper so they're the same dimensions as the objects? Does that help you measure it? No, it's just like literally a replication of the object. Listening to the teacher explain how to line up a ruler? Heck no, adults can't get that sometimes. Watching a teacher demonstrate how to estimate lengths using your hand and shoe. Hand and shoe isn't bad for a small object though, for a paper clip. It's not helpful. Okay, so those are 2 examples that we literally covered in class going over that. There are some other that are extensions that I'll talk about later. Okay, so if you want to look through this and go over this, some of it's from 1350 also. And if you have questions, we can go over questions later. So I won't see you on Tuesday. Make sure you turn in your geometry project, and I'll see you after Thanksgiving and we'll review for your test then.
Have a good Thanksgiving.
You too. Just like, let me stop my recording real fast.